think almost everyone's back. Okay, what do we think? There we go. What do we think? So not all of you have video, but that's okay. Ease of computation, thumbs up or thumbs down? Yes, no, ease of computation? Yes, yes, most definitely yes. Super easy, ease of computation, great. Thank you for the thumbs up. If you're not on video, I don't know if there's an emoji that you can use for thumbs down or something else. We'll have to see for this next one.
There's thumbs up and clapping. Those are the only two we have.
All right, that's great. Well, we'll do clapping for thumbs down, I guess. We can do that. All right. Pre-image resistance, yes or no? Pre-image resistance, yes or no for pre-image resistance? Actually, yes, you're not going to know which message this came from. You're going to have a whole possibility of messages that your hash came from, but you're not going to know which one specifically. So yes, it does have pre-image resistance. That's a good one. Strongly collision-free, yes or no for strongly collision-free? Yes, or we'll do clapping for no. Thank you. Absolutely not. This is ridiculous on strongly collision-free. Same thing on weakly collision-free is not happening, and therefore this is a really bad hash function. It's easy to come up with ones that have the first two or easy-ish. This is a terrible hash function, but it's an example. All right, let's talk about one that is actually a little more practical. So here's my next one. Here we go. This one is a real one. It was developed in 1992, so it's an actual real one. I do not know how widely used it was. That I'm not sure of, but this is an actual one. I did not come up with it myself. Here's your input. So your input is going to be, messages are going to be numerical values, okay? It's going to be x naught plus x1 times q. So q is your parameter in this case. We'll get to a couple more parameters in just a sec, but q is a parameter. So basically we're using the division algorithm with q. Technically, this violates the definition of a hash function. Technically, you can't take an arbitrary length input. So this is not going to satisfy arbitrary length input. Technically, this violates the definition of a hash function. We are going to find that when we talk about SHA-1, also that technically violates the definition of a hash function. And so practically speaking, what we do to get around this is block our message. We've talked about blocking our message before. We're going to break our message up into blocks. That's how we're going to deal with this. So yes, this technically violates the definition, but we'll block our message and it'll be all good. Okay, here are your parameters. So we need a large prime P. And then we also need P to be of the, have the property that P minus 1 over 2 is also prime. And that's the Q back up in this decomposition of the message up here. So we need both P and Q to be prime. And then we need primitive roots mod P. This was on the test. This is why we talked about it. Some of you guys did it, and some of you did non-trivial square roots of 1. So primitive roots mod P. If you don't remember what primitive roots mod P are, go back and look. It's not hugely important for the description of the hash function. It's more important if we were going to delve deeper into the security. Here's our output. So the output is the hash value. It's alpha to the x naught times beta to the x1 mod P. And again, x naught and x1 are coming from the decomposition of your message up here. That's where these are coming from. X naught and x1 coming from the decomposition of your message. Okay, there is an example on the slides. You can walk through that. I won't bother to do it in Perry. There's an example. You can see how this works. It's just basically do some computations. Here we go. I would like you, please, I'm going to put you into breakout rooms one more time, talk about which parameters are satisfied. So one more time, breakout rooms. Here we go. They're opening up. Talk about which parameters are satisfied here. Go. Should be open.